So basically, by seeing this, like first question arrives
Mm.
is like, what is this quantum numbers
Yeah.
and why we have to study this? What is its importance, application, so and so. So
Mm.
the simplest definition of quantum numbers away from chemistry is
Mm.
just like passport. You
Mm.
know how important a passport is. It can track like any information about a citizen residing
Yeah.
in like anywhere in the world. Yes.
Yeah.
So it is basically a something like if you know about like if you have the passport, you can tell all the information regarding to that person or citizen.
Mm.
Yes. Uh, so similarly, just like passport, there are quantum numbers. So
Mm.
quantum numbers is basically a passport of an electron.
Mm.
So it can tell all the informations about the electron. Okay.
Mm.
So like electrons is residing in which shell in an atom and what is the orbitals, how is the energy associated, how is the spin associated, and so on. Okay, we
Yeah.
will discuss. So basically, there are four types. There are four types, and they are like a very important. First one is principal quantum number. Principal quantum number. So let me take this one first. So it is like as a name is saying like it is principal. Principal means which is like the most important of all. It is denoted by small n, small n.
Yeah.
And what it tells about the number of shell. It tells about the number of shell. Okay, like electron is present in which shell or how many numbers of shell are there in an atom. So basically, suppose if n is equals to 1, what does it means? First shell. If n is equals to 2, means second shell.
Okay.
Shell or orbit or energy level, all are like synonyms to each other. This is
Yeah.
third shell. Yes, and so on. Okay, so this is like basic information like which it is telling. Now the values of n. Values of n. So the value of n is from 1, 2, 3, 4 up to infinity. So n
Is
can
it?
have like these values. Like you can say like uh, real number, oh sorry, natural numbers. Yes,
Mm.
this
Yeah.
starts from 1 and ends infinity. So this is all like n can have these values.
Okay.
Now another thing is what are the applications of n? Okay, so applications of n very important. So basically, if you know the value of n, you can tell the number of electrons present uh, in a particular orbit or shell. So first application is like electrons present in shell, and it is given by a formula which is known as 2n square. You can remember.
Yeah.
Like we will do this like suppose if n is 1, like here
Mm.
n is 1. So now if I apply this formula, like the electrons present in the shell. So if the value of n is 1, then
Mm.
electrons will be how much? 2 multiplied by 1 square, that is 2.
Yeah.
And you know, like in first shell or first orbit, we have 2 electrons. Similarly, if
Mm.
n is 2, the electrons will be how much? Total electrons?
What? Four?
2 multiplied by 2 square. So what it will be? 8.
That will be 8.
Yes. So that's how you can go on. So it is like telling you about information about this thing, like electron present in the shell. Second application, This n is going to help you to calculate the energy of the orbit, and
Mhm.
this we will like discuss in Bohr's model. Okay, you can calculate the energy of any shell. Okay, so
Yeah.
if you know the value of n, also you can calculate, just like energy, you can calculate radius
Right.
of the atom. You can calculate the radius of the atom, or like distance of the orbit from the nucleus. Okay, like
Right.
first orbit is how much like far located away from the nucleus, second orbit, third orbit, just like this. So you can also find out the radius, and this you will again discuss in Bohr's model. You can also
Right.
calculate the velocity of moving electron.
Velocity.
Yes, and again Bohr's model. So this may be not in your syllabus, but I am just giving you a like glimpse because you
Yeah.
should know. In your syllabus, it is like energy of the orbit.
Yeah.
Okay, but I am telling you, like you can also calculate, and you can also calculate the like time taken by the electron to complete one revolution, like one
Right.
circle or like whatever it is. So
Yeah.
you can also calculate this. Third thing is this value of n is also like telling you, uh, you can n can be used, n value can be used to found other quantum numbers. Okay, so the remaining quantum numbers, like which we have not discussed yet, so can also be found by knowing the value of this n. So that's why n is very, very like a important quantum number, and it is known as the
Mhm.
principal quantum number. Basically, the n defines the number of shell.
Yeah.
Yes. So I hope like you have understood this. Any doubt regarding this?
No.
No.
No doubt.
So now we are coming to the second quantum number. The most important fact about this n is like first you have to know that it is number of shell, and second is you have to know like what values are associated with this n. Okay, like n cannot have zero value or minus value. It is 1, 2, 3, like you can call it like natural numbers. The second
Yeah.
quantum number is called azimuthal quantum number.
Mhm.
So this is the second one we will discuss. Okay, we can discuss here. So it is denoted by small l.
Mhm.
It is denoted by small l, and what it tells the shape of orbital.
Right.
Now another question in your mind is, what is this orbital? You know orbit, but orbital is new thing for you. So orbital is a place where the probability
Mhm.
finding an electron is maximum. So means a place where the chances of finding an electron is maximum is called as orbital.
Yeah.
Like in an orbit where the electrons can be found, like the uh, most of the electrons can be found is known as orbital. So L value are like telling you the shape of orbital. Now
Mhm.
you must know like there are basically like most common orbitals are four types, or of four types. One is
Yeah.
S, another is P, then it is D, then it is F. Okay, and the name associated with it is sharp, principal, diffused, and this is fundamental. So these are four orbitals, especially associated with this L. Okay. Now we will
Mhm.
come to it like what is S, what is P, what is D, and what is F. We will come to it. Okay. Now we will discuss like values of n. It is known for the shape of orbital. Okay, you
Hmm.
can tell what is the shape of orbital. Now values of L, small l, like azimuthal quantum number. So basically, like L can have, it can have 0 to n minus 1 values.
Hmm.
Like like earlier I told you, like n is also like helping, like the principal quantum number is helping you to calculate other quantum numbers as well. So here is why. So from 0 to n minus 1. So if you know the value of n, you can also calculate the value of L. Yes,
Yeah.
right? So let us start with like n value 1, n value 2, n value 3, and n value 4. We take only these 4 cases. And now you have to tell me the value of L. What can it be? Now for n is equals to 1, what can it be? The value of L. Like it starts from 0 and
Yeah.
ends to n minus 1.
So
So basically, if you,
it is zero. The length is
it is
zero
0.
then.
It will be 0. Very good. Now for 2, can you tell?
It's one.
It's 1. It's 1, but it can be 0 as well,
How?
because it starts from 0 and ends to the maximum value.
Okay. So it can be, all of them can be zero and the number.
Yes, yes. Now for third, can you tell me?
Zero and two.
0 and you skipped 1.
Oh,
It is like
zero.
basically like whole number. Yes, but it starts from 0 and like to n minus 1. So it is basically whole number. You can write because 0 is there.
Mm.
Now can n is equals to 4? Can you tell anything? Please be right on this. You can take time.
Yeah. So 2, 3.
What?
Yeah. 0, 1, 2, and 3.
Very good. Excellent. So this is what like you can like calculate from the values of n. How you can calculate the values of L. Now you will be wondering like 0, 1, 0, 1. Are we like discussing Boolean algebra or like something like that? So another important thing, very important thing regarding this, I am telling here. L, important things, important facts. So this is like really going to help you a lot when you like write the electronic configurations in SPDF form, or basically like knowing about any information regarding the orbitals of the electrons. So these are really very good parameters which can like tell you almost everything. Okay, so now see, generally the values of L we calculated by substituting the above values of n are 0, 1, 2, and 3. These are the 4 values. However, like some shells or some orbits are having only one value of L, and some are having even more than one. Yes.
Yeah.
So how can you decide the shape of like shell, shape of orbital, or like shape of subshell? Orbital is also known as subshell. Okay.
Mm.
So how can you like predict the shape of like orbital? See, now if you are confused like what is shell and subshell or what is orbital, see like if you see a building, suppose I just see a building. This is a building, and the building, here is the ground floor, here is the first floor, here is the second floor. Okay, and maybe here is the third floor. So basically, on the ground floor, like there is no room.
Yeah.
On first floor, there is only one room. Second floor, there are two rooms.
Mm.
Third floor, there are three rooms. So what will happen? Like, see, this is floor,
Yeah.
like 0, 1, 2, 3, and these are rooms associated with it. So basically, if I am having like 0 value, so there is no floor,
Mm.
no room, like ground floor, basically basement. Okay, and see, if I am just having the like Going upper part, like on the first floor, if I go, I will found only one room is there. One is reception and other is room. And if I go more higher, I will found like two rooms on the second floor. This is a type of building. And if I go to the third floor, then I will find like three rooms.
Right.
So basically, if I say like third floor, so what you can say like third floor has three rooms. Yes.
Yeah. Yes.
So similarly, there are shells like first shell, second shell, third shell, and so on.
Mm-hmm.
Yes. Or if I can start with like this is first floor, this is first floor, second floor, third floor, and fourth floor. And I'm changing this. This is first floor. So first floor is having no room. Second floor, one room. Third floor, two rooms. And this is fourth floor having three rooms.
Mm-hmm.
Okay. So see, if there is first floor, there is no room. Like there is basement or whatever it is. I don't know. Maybe a big hall, but no room to sleep. On second floor, there is one reception and one room. On third floor, like so this is a building. Just like these rooms are, there are like orbits or like there are like shells. So in first shell, like there is no orbital. In second shell, like we have one orbital. In third shell, we have two orbitals. In fourth shell, we have three orbitals. Got it? So this is like just like in the atom, something like this is happening. I hope like you can correlate. So basically, like zero value stands for S, one always stands for P, two stands for D, and three stands for F. And you can write this is small or caps, whatever you want. But basically, it's better if you write in small.
Right.
So this is S orbital. This is P orbital. This is D orbital. And this is F orbital. Okay,
Yeah.
got this.
Yes.
So now what this L value is going to help.
Mm-hmm.
Like why we are like calculating these L values. The question is. So basically, if I talk about S orbital,
Mm-hmm.
so S orbital is something like I said, like it tells you about the shape of orbital, the values of L. So basically, S orbital, if I talk about S orbital is spherical in shape.
Mm-hmm.
P orbital is something like dumbbell.
Mm-hmm.
Okay. D orbital is something like double dumbbell. So I don't know about the spelling.
That's right.
So one dumbbell and another dumbbell. So it is double dumbbell, just like a flower. Yes. So these are the shape of orbitals. P orbital, D orbital. Okay, F is like diffused. The shape of F is diffuse and very, very complex. So it is like in the advanced level you study this.
Yeah.
Okay. So have you understood this thing? It's okay,
Yeah.
like you cannot you may not be able to digest it here, but I will take you there slowly and slowly. These are some facts like you should know. Okay. So I hope like you are enjoying. You
Yes.
are? Okay.
Yes.
So this is the values of like L. Now again, there is another parameter like the third quantum number, which is again very, very important. The third parameter is known as magnetic quantum number.
Mhm.
and it is denoted by small m. We will take it downwards. So the magnetic quantum number, the third parameter. So why we are going to study this, the magnetic quantum number? The reason is magnetic quantum number, it helps to predict the orientation of orbitals. Orientation of orbitals in space.
Mhm.
Tells about orientation of orbitals. Like if you have two axes, like or three axes, x, y, and z. So basically, your orbital, like suppose if I am talking about this p orbital. So is it here, or is it here, or is that one is here? So like this, on like the orbital is placed in space in which direction? So that is how can you tell that? Through this magnetic quantum number. It tells you how they are represented in space, these orbitals. Okay. So now for magnetic quantum number, again, next thing is like values of m. This is very important. You should know two things. Like first is like what is the purpose of this magnetic quantum number, and second one, like what are the values it is having. So m can have values. M can have values
Mhm.
minus L to plus L, including zero. Like it is like integers.
Mhm.
Yes. So see, minus L to plus L, M can have values. So what it means, see, like N is helping to calculate the value of L. Yes. And this L is helping to calculate the value of M.
Mhm.
So they are like interlinked. But you should know the value of N to continue to the chain. Okay. So like if suppose if N is equals to 1, what
Mhm.
L can be? 0. L belongs like L is from 0 to n minus 1. Yes,
Yeah. So it's just, yeah, it can only be 0.
0. If L is 0, what will be M?
Also 0.
Yes, M will be also 0. Very good. Now, second one, if n is equals to 2, what will I have? First is L is equals to 0, and second one is L is equals to 1. Yes, we can have two values. Agree?
Mhm.
Okay. For L is equals to 0, M is 0. But if L is equals to 1, then M can be. Can you do this? M is integer.
M will be 1.
No, you can add minus L to plus L. So minus 1 to plus 1, including 0.
Mhm.
Got it?
Yeah.
The third thing, suppose if n is 3. Now, this you have to do yourself. Yes, you tell me and I will write.
Mhm. Right. Um, so L can be 0, 1, or 2.
Very good.
On L is equal to 0, the M is 0, and L is equal to 1, it is minus 1, 0, or plus 1.
Okay.
And L is equal to 2 will be minus 2 minus 1, 0, 1, and 2.
Wow, excellent.
Thank you.
So this is all about quantum numbers. Like you have done like almost like the major part. Okay. Now in this thing like -1 0 +1, you can write either -1 0 +1, or you can also write like +1 0 -1. Both are correct. Okay, according to the your textbook, you have to follow. Both are correct. Like you can have the choice to write -1 here or +1 here. Yes. Like okay, you can begin with +1 or you can also begin with -1. Okay. Now see what is the importance of doing all this stuff we are doing. So this I would like to show you this by the example of like orbitals, like shape of orbitals. Okay. Now basically, uh, see, we want to make it more interesting, like here. So you know, like L is 0 here, L is 0 here. For L is 0, what is the orbital associated with it? It is S orbital. Yes,
Yeah.
I have told you like there are like this. You have to remember this. This is very, very important. These facts are very, very important. Like L is 0, so it is S, L is 1, it is P, L is 2, it is D.
Yeah.
This is sufficient. 3 are sufficient. So basically it is S here. Now this L is 0, so again it is S. And this is 1, so it will be P. Yes. Similarly, we can write for this as well. So S, this is P, and this will be D. Yes, correct. See, now, see, if N is equals to 1, L can be 0, and if L is 0, it is means S orbital. Yes, and as it is S orbital, also if L is 0, we know M is 0. Like orientation of orbital in space is 0. So basically, S orbital looks like this, a sphere, spherical. And it is like independent of direction because M is 0. So it does not depends on direction. Yes, it has non-directional characteristic. Okay. Now, see second case, if N is 2, L can be 0. 0 is already discussed. And L can be 1. Now 1 need to be discussed. For value of L, if it is 1, then which orbital is associated? P orbital.
Yeah.
So basically, if it is a P orbital, like we know, like the shape of the P orbital is dumbbell. Okay. So now for a value of L, we can have 3 values of M. Like M can be -1, 0, and +1. Minus L to plus L. So it means there are 3 directions or something like that. Okay. Or like 3 ways like in which we can place our orbitals. So basically the 3 ways are, see, the first one is like if you draw p orbitals in this form. Second one is if you draw p orbital in this form. Third one is if you draw p orbital in this form. Like see, if these are some axes, this is px, this is x-axis. So basically you write this orbital as px. Why? P orbital on the x-axis. As you see, like this axis is similar to y-axis. So as the p orbital lies along the y-axis, you can write this orbital as py. And now this orbital, see, this is along the z-axis. So you can write like it is pz. So for a particular value of L, like 1, you can have 3 orientations of these orbitals. Like either this orbital can be placed in x-axis direction or y-axis or z-axis. And depending on which direction it is placed, you will write it as px or py or pz. Got this? Have you understood this?
Yeah.
No? So basically I can write this is px, this is py, or this is pz. This can change, like X and Z can change, interchange. In some books there are something, and in some books there are other ways. But basically the like concept is same.
Yeah.
Okay. Now another thing is, like suppose maybe I don't know whether it is a part of the syllabus or not. For n is equals to 3, we have calculated the values of d, like m is this and this. So I don't know whether this is in your syllabus or not, but I will going to teach you like this topic as well for the D shapes, because this will be important for you. And this will be
Yeah.
like you have advanced level, so this should be in your syllabus. Okay. Now see, like for s orbitals there is only no like non-directional, and for p orbitals there are 3 directions: px, py, and pz, corresponding to the 3 values. So 3 values means 3 orientations. Like D is having 5 values, so it should have 5 orientations. Yes. Now we will see. Now suppose n is 3, so L can be 0, L can be 1, and L can be 2. So these all are discussed, 2 is remaining. So for L is 2, you can have 5 values of M. Yes. So the values of M will be -2, -1, 0, +1, and +2. You have 5 values. Yes, earlier we have discussed this. Now because you are having 5 values and the shape of the orbital is dumbbell. So now how to represent these 5 orbitals in space, because M tells you about the orientation of orbitals in space. So now how can you like design these? So firstly, let me make these axes, because these are 5, we need 5 axes, like 5 such diagrams. Let me make some adjustments. Are you understanding this? This may be very new to you, but it's okay.
Yeah.
You will enjoy it. You will enjoy it.
Mm.
New concept, but this is very interesting. Maybe you are not bored in this class. Suppose this is X, this is Y. Suppose this is X, this is maybe this is Y, this is Z. Call this anything you can call, like 2 X's you have to take. Suppose this is X, this is Z, and this is X, this is Y, and this is Z. Okay, so these are 5 cases. It's so see what is happening here. Like suppose, because it is double dumbbell, it is double dumbbell. You know this. So dxy, dyz. So this orbital is naming dxy. This is dyz because the lobes are in yz directions. Now this is dzx or dxz. This will be dx square minus y square, and this will be dz square. So these are 5 like uh, orbitals associated with this, like d orbitals, which we have 5 more in it. So basically if I want to draw this on the screen, so this looks like this: dxy, 1, 2. It is like double dumbbell. Similarly, same is the case with this, and this one also same. Okay, now the rest of the other two, like dx square minus y square and dz square, are very important. See carefully how will you draw this. Dx square minus y square is like something like this. Now there is a difference between like previously drawn orbital from green and red. And can you spot the difference between these two? This is dz square, like this. It's a shape. These are the shape of these like orbitals. So can you tell me like why I've used 3 like of the same kind and 2 of the different kinds? Why? Can you spot the difference? There is no chemistry in it, just a common sense.
There's different patterns.
Yes, patterns. Yes. How?
Well, the first 3 have equal patterns.
Yes, you can say that. And any other difference? other than this?
Yeah, the letters are differently adjusted. So DZX, DZY, DN, Y, DX, Y, sorry. And the last two have squared numbers in them. So DX squared minus Y squared, DZ squared.
Okay.
And they
So
have
yes.
different
So
patterns.
basically, what is the difference? Like, see, these are the lobes of orbital.
Mhm.
These are the lobes of orbital. So in these three cases, earlier three cases, what you are seeing in these three cases is like lobes of orbital
Mhm.
are in between the axis. Yes,
Mhm.
lobes of orbitals are in between the axis, like C is in, this is between X and Y, like not lying. And in these two cases, lobes of orbitals are along the axis, like they are lying on the axis. Yes. So
Yeah.
this is the most common and very important difference. See, in between and axis, this is the all rest is all same. Okay, so these three orbitals, like one dxy, dyz, and dzx, these are known as T2G orbitals,
Mhm.
and these are known as EG orbitals. This T2G and EG orbitals are like some terms derived from symmetry, a group theory. This advanced topic, but I am giving you some knowledge. Why? So that you feel confident that you know all this. So we will discuss this T2G and EG in like transitions whenever there is spectra or transitions of electrons. Okay, so that in coordination chemistry, this is very helpful. Okay, but you should know this because these are all associated with quantum numbers. So we have discussed like these three quantum numbers. The fourth one is remaining, and we will discuss it in our next class. Okay. So do you have any doubt regarding this?
No.
No. Okay. So see you in the next class. Thank you.
Right.